Now we will discuss question number 11 of paper 1 code 5. In this question is from photoelectric effect, and in this question we have to show the diagram between stopping potential and wavelength of light and stopping potential and 1 by wavelength of light. Okay, at first the stopping potential as per photoelectric effect, stopping potential is the maximum kinetic energy of ejected electron divided by E, and the maximum kinetic energy from the Einstein equation, that is h nu is the energy of photon minus phi is the work function of the metal surface. Okay, now we will convert this K max in the form of wavelength, that is hc over lambda minus phi. That means our stopping potential in the form of lambda is hc over lambda minus phi divided by E. That means the stopping potential that will be equals to hc divided by E into 1 upon lambda minus phi divided by E. Okay, that means when wavelength of light will be increasing, then the stopping potential will decrease. Okay, but we can draw the diagram up to the threshold wavelength, because after threshold wavelength photoelectric effect will not be found. So the diagram between stopping potential and wavelength will be a decreasing function, but this function will be up to the threshold wavelength. Now we want to draw a diagram between stopping potential and 1 by wavelength. That means because our stopping potential is hc divided by E into 1 upon lambda minus phi divided by E, because 1 by lambda is used in the diagram, so we can say that V naught is equal to hc divided by E into x minus phi by E. That means we are going to draw the diagram with respect to x, and this is a linear function, this is a straight line. That means the stopping potential versus 1 by lambda, which is I have shown x is a straight line, and this diagram will start from 1 upon lambda th. This is the threshold wavelength. Okay, as per the question, our option A and option C will be correct.
Morning students, we will discuss question number 12, paper 1, code 5. Okay, first of all I will read the question. Consider a vernier caliper in which each 1 centimeter on the main scale is divided into 8 equal divisions and a screw gauge with 100 divisions on its circular scale. In the vernier caliper, 5 divisions of the vernier scale coincide with the 4 divisions on the main scale, and in the screw gauge, 1 complete rotation of the circular scale moves it by 2 divisions on the linear scale, and then we have to check 4 options. So let us further move. We will first of all we will calculate the main scale division value of the vernier caliper, then we will check out the least count. So let us move for the solution. First of all, we will calculate main scale division as given in the question for the vernier caliper. So main scale division will be equals to 1 centimeter 1 by 8 centimeter, because 1 centimeter is divided into 8 equal parts. Okay, and as given in the question, 5 parts of vernier scale divisions coincides with the 4 parts of main scale division. Therefore, vernier scale division is equal to 4 by 5 parts of main scale division. As we know that the value of least count is equal to MSD minus VSD. If we will subtract the vernier scale division from main scale division, that is the value of least count. So the least count here will be equals to 1 by 8, that is our main scale division, and for the vernier scale division 4 by 5 parts of main scale division. So if we will calculate the list count, this will be equals to 1 by 8, 1 minus 1 by 4 by 5, that will be equals to 1 by 5, and that is equals to 1 by 40 centimeter. Okay. Now if we will solve it, it will be equals to 0.025 centimeter. So this is the value of list count for the vernier caliper. If we will divide 1 by 40, the answer will be 0.025. Now let us check the question. The option A, if the pitch of the screw gauge is twice the least count of the vernier caliper. So pitch of the screw gauge, has been given as equals to the twice of least count. So twice of least count of the vernier scale, so twice into 0.025. So that will be equals to 0.050 centimeter. So this is the value of pitch. Okay. Now we have to check the least count. So if we will check the least count, then the least count will be equals to pitch by 100, because the circular scale on the screw gauge is having the 100 parts. So this will be equals to 0.050 divided by 100. So this will be equals to 0.0005 centimeter. Now let us check the options. If we will see here, we will see that option A is wrong and the option B is correct. If we will change it into the millimeter, this will be equals to 0.005 mm. So the option B is correct. Option A is wrong. Now we will check the option C and D. Option C, if the least count of the linear scale of the screw gauge is twice the least count of vernier caliper. Okay, so now we have been given that the least count of linear scale of the screw gauge is twice the least count of vernier caliper. So least count of linear scale of a screw gauge is equal to twice of least count of vernier caliper. So we have already calculated the least count is 0.025. So this will be equals to twice into 0.025. That will be equals to 0.050 centimeter. Now we have to calculate the least count of the screw gauge. The least count of the screw gauge is equal to pitch by 100, and the pitch is always twice of linear scale as it has been given in the question. So twice into 0.05 divided by 100 will be our answer. Now if we will solve it, this will be equals to 0.100 upon 100, and that will be having the value as 0.001 centimeter. Okay, so this is our option of C and D. If we will see, the option C is correct because it has been given in the millimeter. So the answer will be option C is the correct, option D is wrong. Thank you.
Dear student, I am going to discuss the question number 13 of paper number 1 JEE Advanced 2015. In this question, if we consider the Planck constant h and speed of light c and gravitational constant g as a fundamental quantity, then we have to calculate the unit of mass and length L in terms of these three quantities h, g and c. Okay. Now from any general formula, say we know that E is given by hc by lambda. Okay, and the potential energy of system of two masses is given by G m1 m2 by R. Here lambda is the unit length L and this is also L, so that we can cancel, and we can assume the m1 is equal to m2. Okay. So from this equation we can just write down HC is directly proportional to Gm square. From this equation we can write m is proportional to root of Hc by G. So that from this equation m is directly proportional to root H, m is directly proportional to root C, as well as m inversely proportional to 1 upon root G. So from this equation we can simply write m is directly proportional to root C. So A option will be correct for A option. Now say for any second case, E is equal to, we can write mc square is equal to Hc by lambda. Here we can write down lambda is equal to Hc upon H upon mc. From this H is equal to H upon, put the value of m from this equation, root of Hcg. So very clear from this expression we can write lambda means length L. L is directly proportional to root of G and L is directly proportional to root of H. So we will get the more two option. Option number C is L is directly proportional to H, and option number D, L is directly proportional to root G. So that correct answer will be A, C and D. Thank you.
Morning students, we will discuss question number 14, paper 1, code 5. First of all, I will read the question. Two independent harmonic oscillators of equal mass are oscillating about the origin with angular frequencies omega 1 and omega 2 and have total energy E1 and E2 respectively. The variation of their momentum with positions are shown in the figure. If A by B equals to n square and A by R equals to n, then we have to choose the correct options. There are 4 options and we have to choose the correct options. Okay. So in the question we have been given that we are having the two oscillators and the graphs has been given to us. The graphs are between the position and the momentum. The amplitude of the momentum has been given as B and the amplitude of the displacement has been given as A. And in the second oscillator, the graph is a circle, therefore the amplitude of momentum and the amplitude of position are the same and it is equal to the R. And we have given the two parameters here, A by B equals to n square and A by R equals to n. So let us move to the question. In this question we can see that the first graph is of ellipse. So we have the options here. We have the graph in this way, p square upon b square plus x square upon a square will be equals to 1. If we will solve the value of p square from this graph, we will find out 1 minus x square upon a square multiplied by b square. Okay. Now we have to move further and we want to calculate the value of v square, because we know that the momentum is equal to mass into velocity. So this will be equals to a square minus x square multiplied by b square upon a square. Now the velocity will be equals to a square minus x square multiplied by b square upon m square a square. If we will solve the value of v, we will find out b upon am root of a square minus x square. We have just taken the square root on both the sides. Now v is equal to b by am root of a square minus x square. As we know, for the SHM, the equation of velocity is equal to omega root of a square minus x square. The omega is the angular frequency and A is the amplitude of displacement. The x is the instantaneous displacement. If we compare here, on comparing both the equations, let us say this is our equation 1, this is our equation 2, this is the standard equation for SHM for the velocity. So on comparing both the equations, we will find that omega is equal to B by AM and the small a is equal to the capital A, amplitude is equal to small a. Okay, so this is our equation for the first oscillator. Similarly, if we will see for the second oscillator, we would name it as omega 1 and this is our A1 for the first oscillator. For the second oscillator, we will go to this graph and here we will find out that P square plus X square is equal to R square, because it is the equation of P square plus X square is equal to R square, and this is the graph for circle. So here P square can be written as R square minus X square, and for momentum, if we change it into the velocity equation, this will be equals to V square can be written as R square minus X square 1 upon M square. Now the equation of velocity can be written as 1 by M root of R square minus X square. Again we will compare the equation for the second oscillator with the standard equation of SHM, and we will find out that the omega 2 can be written as 1 by M, and also the amplitude for the second oscillator is equal to R. So we have here 4 results. These are our results for the first oscillator and these are the results for the second oscillator. Now we have to see here the parameters given to us, A by B equals to N square. So here we can check the value of A by B. If I will check the value of A by B here, it will be equals to A by B can be written as 1 by M omega 1, and that is equals to N square. So we will find the value of omega 1 is 1 upon M N square. We know the value of omega 2 is 1 by M. If I will divide omega 1 by omega 2, I will find out the value as 1 by N square. Okay, let us see the options. What are the options? We are having the option number 2, omega 2 by omega 1 is equal to N square, and we are having here omega 1 by omega 2 is equal to 1 by N square. So we can see that the option B is correct. Of course, option B is correct, then option C cannot be correct. Now we have to see the option A and option D also. Here we have to calculate the value of E1 and E2 also. So I will omit, and we will find out the values of E1 and E2 also. The value of E1, the total energy of SHM, the body executing SHM is equal to half M omega 1 square A1 square. So let us put the values of omega 1 here. We have the value of omega 1 as B square upon A square M square, and the value of amplitude A1 is given as A square. So the value of E1 can be written as here B square upon 2M. The same way the value of E2 is equal to half M omega 2 square A2 square, and this will be equals to half M omega 2 has been calculated as 1 by M square, and the value of A2 is equal to R, so this will be equals to R square. So I can write E2 as R2 square by 2M. So we have calculated the value of E1 and E2 also. Now we have to see the options, whether option A is correct or option D is correct. Okay. So the option A is about E1 omega 1 is equal to E2 omega 2. Let us see it. E1 omega 1 is equal to E2 omega 2, whether it is correct or not. E1 is equal to B square by 2m, and omega 1 we have calculated as B by AM, and E2 is equal to R square by 2m, and omega 2 we have calculated as 1 by m. So let us see whether they are equal or not. If we calculate it, it will be B cube by 2am square. Here it is equal to R square by 2m square. If we cancel 2m square by 2m square, it will be here B cube by A is equal to R square. So if we see A by R equals to n, here let us see here A by B equals to n square, so we can change it in this way, B into B, B by A into B square is equal to R square. B by A will be equals to 1 by n square, and this is equals to B square, and the value of R square can be written as A square upon n square. We will see here that the left hand side is not equal to right hand side, so the option A is wrong. Now let us check for the option D. Option D is about the ratio of energy and angular frequency. We have to check whether E1 by omega 1 is equal to E2 by omega 2. So E1 is equal to B square by 2m. The value of omega 1 is equal to B by AM. So the left hand side is equal to AB by 2, and if we check the right hand side here, this is equal to E2 by omega 2. The value of E2 is equal to R square by 2m, and the value of omega 2 is 1 by m, so I will write it is equal to R square by 2. If we will check AB by 2 is equal to R square by 2 or not, the value of AB can be written as, let us remove the value of R in the terms of n, it can be written as A square by 2n square here, and if you will see AB by 2, let us check the value of AB by 2 here, so it will be A by 2, and the value of B can be written as A by n square. So this is equals to A square by 2n square. So the value of left hand side is equal to right hand side. So finally our results are the option B and D are correct.
Dear student, I am going to discuss the question number 115 of paper number 1 of JEE Advanced 2015. In this question, initial condition is this one. A ring have mass capital M and the beads, very small beads of mass m by 8 placed at the axis. And the initial angular velocity of the ring is omega. As the ring start to rotate, after certain time, the position becomes this one. In this case, the bead number A at a distance 3r by 5, and the system have angular velocity 8 omega by 9, and we have to calculate the distance of particle B from the axis. So this is a very simple question, and it is related with a conservation of angular momentum of system. So just we apply the equation for conservation of angular momentum. L initial is equal to L final. Initially the particle is at axis, so that moment of inertia will be 0. So just we will consider the moment of inertia of the ring. So that we will write mr square multiply by omega. The moment of inertia of both particles is 0, so that simply we equal. Now in this case, first we consider the angular velocity of the system 8 omega by 9. For ring, mr square into omega 8 omega by 9 plus. For this particle, the mass of this particle is m by 8. M by 8 r square 3r by 5 whole square into omega means 8 omega by 9. And for particle B, m by 8 r square 8 omega by 9. So this is a simple equation. Now just we calculate the r, and from this equation we will get the r is equal to 4r by 5. This is the final answer, 4r by 5. Thank you.